Our next speaker is Dr. Thomas Jones. Dr. Jones is a planetary scientist, former NASA astronaut, author, and speaker. He graduated from the Air Force Academy and was an Air Force B-52 pilot and aircraft commander before earning a doctorate in planetary sciences from the University of Arizona. Tom worked at the CIA and as a consulting scientist before flying 4 shuttle missions with NASA from 1990 to 2001, and he has worked for nearly 53 days in space. Tom is currently a senior research scientist at the Florida Institute for Human and Machine Cognition and is a frequent cable news commentator on space-related issues. His latest book titles are Planetology, Unlocking the Secrets of the Solar System, published by Random House, and Skywalking, an astronaut's memoir, published by HarperCollins. Please join me in welcoming Dr. Tom Jones.
So yes, George, I'm ready to go. I'm still working on that $100 million, though. Well, it's a pleasure to be with everyone today, and I'd like to thank the Smithsonian and the Air and Space Museum and the Lemuelson Center for inviting me to speak about our human future in space, moving beyond Earth. So it's my pleasure to tell you about my imagination for the next couple of decades, perhaps the next 30 years in human spaceflight. There are a lot of exciting possibilities, and we can discuss whether some are more likely to happen than others. But one thing I can assure you of is that the human curiosity and drive to get into space, to explore strange new worlds, if you will, is undying. And despite our budget travails in the present, I think there's always going to be this drive across the globe to propel human explorers to new heights. And I was lucky enough to serve during the what they find her soon. Lost in space, so to speak. I had the pleasure of serving on the space shuttle on 4 trips aboard the orbiter fleet and helped build the International Space Station, the model of which you see over here in the gallery. That's a good jumping off point, I think, for our conversation today about innovation and invention and the human expansion into space. On my last mission, I was up on the shuttle Atlantis at the International Space Station helping install the U.S. Destiny Laboratory. And that was sort of the peak experience of my shuttle career. And it certainly meant to me the realization of a dream that I'd had since I was a child. And it continued on from the age of 10 or so until I achieved my dream come true, being hired by the space agency NASA with the astronaut class of 1990, 20 years ago. This is the patch that our astronaut class put together. And you can see in 1990, when my group of 23 fellow astronauts came together, we called ourselves the Hairballs. And if you want to know why we were called the Hairballs, you can read my book, Skywalking. But this is our official patch. You can see 23 stars around the periphery for the 23 astronaut candidates in our group. You see the space shuttle, which we all hope to fly in the next few years. And you also see the moon and Mars, as well as the Earth being circled by the space shuttle, and the astronaut emblem in gold on the patch. One notable thing that's absent in that patch is the space station. The space station was just a concept that was getting off the ground in 1990, and none of us really believed that we'd be involved with the space station because we wanted to go on to the moon very quickly and then get on to Mars. That was the directive to NASA from President Bush #1 back in 1990. That plan died very quickly, and we refocused our goals on serving on the shuttle and then helping build the International Space Station. But our dream of expanding into the solar system was very strong amongst our 23 classmates, and we were really hoping that we'd be the generation to do that. It didn't work out that way. Dare I go on, Eric? That's okay. So we thought that we might have a chance to go to the moon and Mars. That didn't work out for me. But we certainly hoped, and I think it's true, that our work on the space station over the last 15 or 20 years has put us in a position to jump off to those destinations with decisions to be made by our government and other governments around the world. Now, let me just acquaint you very quickly with my space shuttle career. I had 2 flights aboard the Shuttle Endeavour in 1994. They were missions to planet Earth, and as a planetary scientist, it was wonderful to look down on the Earth from 120 miles up and have the experience of that global view of the Earth, seeing the Earth as a planet as we studied it with radar energy and looked for change across the face of the planet. Just an incredible human experience to look at the beauty of our planet for 11 days in a row on each of these 2 missions in 1994. And then in 1996, on this very day, this is my anniversary of my 3rd launch into space aboard the Shuttle Columbia. And it was great to fly on the historic shuttle, the first one that flew into space, the Columbia. And we had 2 satellites in the cargo bay of the shuttle locked up in there for release into orbit on a science mission to study astronomy and astrophysics and also to look at material science in orbit. And in the course of that mission, we deployed and retrieved 2 satellites in orbit 220 miles up, came back home in early December after an 18-day mission aboard the Space Shuttle Columbia. And while we were in space, we had Thanksgiving. We launched November 19th, had Thanksgiving dinner, and if you were here for the last panel, we had some pretty decent Thanksgiving food. We had shelf-stabilized Dinty Moore turkey dinners. The convection oven on the shuttle got them up to about 150 degrees, so we had some sort of lukewarm mashed potatoes and gravy and turkey. We had some 10-day-old rolls that we had brought with us from Cape Canaveral. But we did have some freeze-dried asparagus, which was very good, and we had freeze-dried strawberries for dessert. And I think altogether, it was an adequate Thanksgiving dinner for space travel. It's certainly one of the most memorable Thanksgivings I'm ever going to have. When we came home, it was after the longest space shuttle mission ever. And here's the Columbia back on the runway at Cape Canaveral. There's my crew of astronauts. From the left, you see me, Ken Cockrell, the commander next to me, Story Musgrave in the middle, Tammy Jernigan, also a mission specialist, and our co-pilot, Kent Rominger, on the right. There's our beautiful ship, Columbia, on the runway. Nearly 18 days in space, the longest space shuttle mission out of all 135 missions. So we share that duration record aboard the shuttle. I got a chance to fly for the 4th time on the shuttle Atlantis, starting in February of 2001, just about 11 years ago. And this was a mission to the International Space Station. This is our liftoff from Cape Canaveral on February 7th, 2001. And you can see how gorgeous a launch we had. We were soaring about 20 miles up there at the end of that smoke plume. The rays of the setting sun caught our exhaust plume and sent a shadow all the way to the face of the moon that was rising over the Atlantic Ocean. So I have the duration record on the shuttle, and I have the record for the most beautiful space shuttle launch ever. And nobody's ever going to be able to take that away from me or my crew. We rendezvoused with the space station about 2 days later, and in the cargo bay of the shuttle Atlantis, you see the Destiny Laboratory. It looks like a big soda can. I guess I should point over here. Most of you can see this. That's a school bus-sized laboratory called Destiny, the American centerpiece of the space station. Cost $1.4 billion, and there's only one of them, so our job was to put that safely into place at the space station. There's the laboratory in place on the 4th day of the mission after our arm operator, Marcia Ivins, moved it into its proper berthing spot and bolted it down with the shuttle's robot arm. And then the spacewalkers took over to do the installation. This is me on one of 3 spacewalks connecting up the utility lines on the laboratory from the space station to the lab, providing electrical power and computer commanding capability, and also those big fat white hoses are the cooling lines to air condition and cool the systems and experiments aboard the Destiny Laboratory. And I have to tell you, the 3 spacewalks that we did out there were completely unworldly experiences, far beyond what I thought would be the thrill of spacewalking. They were awesome. They were the fulfillment of a dream I'd had since I was 10 years old. While I was out on my 2nd spacewalk, floating around in my own little spaceship, my spacesuit, I heard an announcement from the Capcom in Houston that an American robot spacecraft, the Near Shoemaker, had landed on the asteroid Eros, the largest near-Earth asteroid, about halfway around the Earth's orbit from our planet. And the spacecraft survived the touchdown and was radioing back scientific data to us. And as I did my spacewalk, my 3rd one on the flight, after floating around the interior of the laboratory, I was out on my 3rd spacewalk, and I imagined how, of course, beautiful the view was out through my spacesuit visor looking down at the Earth. But I also thought, looking out into the cosmos from 220 miles up, how astronauts would one day travel beyond just the confines of low Earth orbit, back to the moon certainly, and then maybe to these nearby asteroids to unlock the secrets of the birth of the solar system and to take advantage of the many resources out there, which I'll touch upon in a minute. So that was my dream leaving the space station, was that somebody would stand on our shoulders and get out beyond low Earth orbit, or beyond Earth orbit, BEO as we call it. Here's the space station today, and it is our classroom at least for the next 10 years, and it's the focus of the American space program now that the space shuttle has retired. We get our astronauts up there on Russian rockets, but you can see the American laboratory, still Destiny, at the center of the station, along with European and Japanese labs. The place is an immense complex. Here are some statistics on the space station. It weighs nearly 1 million pounds. It's going around the world about 5 miles every second, about once around the Earth every 90 minutes. If you get up tomorrow morning at 5 a.m., you'll be able to see the space station going overhead here at Washington, D.C. Look to the northeastern sky, look a bright star at about 5 a.m. And check out my website if you want to find out where it's going to be coming up on any given day from your location around the world. But laboratories from 3 countries creating a great environment for fundamental research and for testing the systems that we need to go beyond Earth orbit. Some examples of the research on the station. On the upper left, you see some of the biomedical experiments. These are salmonella bacteria that have been raised on the space station and on the space shuttle. And a vaccine to prevent pneumonia can be applied by administering these harmless salmonella vaccines. They're food poisoning bacteria, but they've been disarmed. And we found out that by growing them in free fall on the space station, we learn more about the genetic switches that can infect people on the ground, and we can learn how to turn off those switches. So those biomedical discoveries may very well lead to a vaccine for pneumonia here on the ground. It's a very dangerous Streptococcus pneumonia bacteria. On the upper right, you see the use of the space station as a plant growth chamber to enable us to grow a biosphere in orbit that can someday provide life support and food for future crews traveling in deep space. On the lower left, you see the alpha magnetic spectrometer looking into the very origins of the universe by detecting cosmic rays that may tell us about the origins of dark matter and dark energy, the very fundamental substances of the universe. And on the lower right, we may be able to test in the next 10 years small independent spacecraft that can then explore the surfaces of nearby asteroids, the moons of Mars, for example, and help us maintain a spaceship on the way to another planet like Mars. So let's unpack that a little bit. These are the possibilities technically of what might happen. How likely are they really to happen in the future? You've got 2 reasons, I think, for humans to be in space. In the 1960s, it was for national pride with the Apollo program on the left. That's not sufficient anymore to justify the budgets of sending people well beyond Earth orbit to the moon and beyond. I don't think national pride is a sufficient strategy or rationale. There are too many other priorities in our country with its deficit problems to mount a budget like this, even with international collaboration. The other reason to send people into space is to solve problems. Back in the 60s, it was to help win the Cold War. Now we can think of humans as applying their particular unique skills over and above what robots can do. We've got, of course, physical dexterity. You've got the brain, the hand working together that can manipulate things, do repairs on the space station solar arrays like we see with my friend Scott Parazynski here. We've got versatility, adaptability, flexibility, where humans can adapt to changing situations, solve problems on the spot. And with the distances involved in going to the moon and the asteroids and Mars, you won't be able to control things in real time from the ground. So having humans there may be the key to actually succeeding at a scientific mission. Problem solving and communication are also very important. Humans can tell us what it's like to experience these new environments. You send people into space, deep space in particular, when these unique traits are needed. Some of the locations we might employ humans in space might be the Lagrange points. These are points in the gravitational field of the Earth and the Moon and the Earth and the Sun where spacecraft can remain stable, like at L1 and L2 here on either side of the Moon, with a very little expenditure of rocket fuel. And you can imagine human explorers going to those initial points, then down to the lunar surface, and expanding our ability to understand the Moon's history and the science and resources that it offers. At those points, the Lagrange points in Earth-Moon space, we can think of repairing large telescopes like we've done with Hubble in the upper left. And in the lower right, here's a sketch of astronauts actually constructing huge telescope mirrors inside an inflated bubble in space between the Earth and the Moon at the L1 point, for example. And then later, those segments assembled by small, tiny people right here can be built into giant telescopes that can detect Earths around other stars. That's the kind of job that you want to give people in space, where robots can't do the job. Only humans can solve the problems of creating these mammoth structures to look back at our own world and then search for other worlds beyond. That's possible in Earth-Moon space. Then we want to return to the surface of the Moon, pick up where we left off with the scientific exploration of our nearest neighbor in space, and find the resources that are there. And here again, unique human skills required. Jack Schmitt on Apollo 17 on the left. Our lunar probes in orbit today have found caves on the lunar surface. These are lava tubes, billions of years old, where we may be able to construct habitats underneath the lunar surface, protecting us from radiation, delving into lunar geology on our next expeditions there. The same spacecraft we build for going back to the Moon, like the Orion, can take us out to the nearby asteroids. We leave the Earth and the Moon behind. We go out a few million miles and start to talk about asteroid exploration. Why? Well, they run into us, and we're certain to be hit by another asteroid in the future. Our very survival as a human species depends on us being able to operate on these bodies and learn how to manipulate them. The second reason is because they're chock full of resources. Some asteroids are 20% water by weight, and we may be able to refuel our spaceships of the future by extracting that water from the wet asteroids that we know that are out there. We might attempt spacewalks on their near weightless surfaces. We might actually deploy those space pods tested at the space station to explore in a shirt sleeve environment. I certainly would like to have a peanut butter and jelly sandwich while I'm exploring an asteroid, which I could do in a space pod, but not in a space suit. And eventually we'll be able to build extraction plants on asteroids and ship the resources back to Earth-Moon space for industrializing space. Using technologies like impact and nuclear explosives and even a gravity tractor, we can learn how to drag these objects off a collision course with the Earth. And finally, with our space legs stretched by our experiences at Moon and the nearby asteroids, we can think of exploring Mars for scientific reasons, if for no other ones. The very origins of biology in our solar system might be locked up in fossils or in actually surviving microbes on the red planet. And you see some robot pictures from our Mars rovers on the top tier of photographs. We're about to launch next week the Curiosity rover in the lower right corner to do a detailed surface exploration for traces of biology on Mars. And then that might lead to the initiative for human explorers to get there. It's only this question of Earth's life's origins that might drive us to Mars one day. I don't think there's a commercial payoff. The curiosity of the human species is what I think takes us to Mars. But I don't think we're going to get there just on governments funding that voyage. We're going to have to build government spaceships, certainly, to take us into deep space and carry us between the Moon, the asteroids, and then on to Mars with international modules provided by our space station partners, for example. But the real question is, can we overcome the hazards involved? We have radiation damage, breaking DNA down from cosmic rays and solar flares. We have the question of staying healthy in free fall for months at a time on these deep space voyages. We're already working out weightlifting exercise equipment on the space station. But is that sufficient to protect humans? Another question that's unsolved is, can we pool the resources together? Here's the federal budget, 100 squares for 100% of the federal budget. This is entitlement payments. This is national defense, about 20%. And here's NASA at 1/2 of 1% of the federal budget. Folks, that's not enough to go to Mars on. It's going to have to be bumped up. Space Commission in 2009 recommended that we could go back to the Moon, onto the asteroids with deep spacecraft if we anteed up about another $3 billion per year. That's about 0.6% of the federal budget. So we have a decision to make as citizens to recommend deep space as part of our ambitions, or whether or not we're just going to be content to stay at the space station in low Earth orbit. So that's a political decision. We talk to our representatives, they talk to the president, we work out jointly leadership positions that could lead us to exploring the asteroids, building solar power systems that can change our energy sources for the 21st century and beam clean, limitless power back to the Earth. That's one of the biggest payoffs, I think, that will come out of this century's exploration of our nearby and distant spaces. Now, the United States has been in space been an exploring country for 200 years. Lewis and Clark looking for commercial and scientific opportunity and discovery in the Northwest. In the 1960s, exploring the Moon. Whether we go to deep space again, whether we go back to the Apollo landing sites, whether we explore the Moon and its resources, whether we tap into the resources of the asteroids, depends on us and the decisions that we make. We need to decide whether our human curiosity and our thirst to be competitive economically in the 21st century merits spending those resources to take us out to the asteroids. And I think most important of all, it's going to take some leadership, both at the citizenship level, at our representative level, and certainly at the presidential level. Human spirit and curiosity cannot be turned off. Those are always going to be present. Whether we can marshal them together to achieve our goals in space exploration and achieve our destiny in space is an open question. Pioneering space is really a choice, and it's not at all assured that the United States is going to continue to be the leading pioneer in space. So it's really up to us. Will we be content with just looking back on Earth from just a couple of 100 miles up, like my friend Tracy Caldwell here? Or will our imaginations and our desire to be a competitive power in the 21st century create a new generation of Lewis and Clarks for the 21st century? Thank you very much. A quick commercial for the 3 books that are in the bookstore out there. Thank you.